Hello everyone, hope you are doing well. Today we learn about a branch of mathematics known as algebra. Like we have branches in science, namely physics, chemistry, biology. Similarly, we do have branches in mathematics, and one of those branches is algebra. And before starting with algebra, let's recollect which branch of mathematics we have learned so far. So the branch of mathematics that we were dealing with till now was arithmetic. Now what is arithmetic? Arithmetic is that branch of mathematics in which we study about numbers and the relationship between numbers. Right? Like how? For example, till now we learnt about counting. We learnt about how to add different numbers together. Like over here, how to add 23, 45 and 67 together. How to subtract different numbers. We learned how to multiply different numbers and even how to divide, like how to do 105 divided by 3. Even we solved complex problems related to just numbers. So everything till now was based upon numbers, and this branch of mathematics was known as arithmetic. Now the thing is, what is the difference between arithmetic and algebra? So let's learn about it. Algebra. Like in arithmetic, we were just dealing with numbers. In algebra, we learn about alphabets. So you will see alphabets in this branch. So the branch of mathematics in which we study about alphabets and the relationship between alphabets is known as algebra. Here you will get to know how to add different alphabets together. How can I solve A plus B plus C plus A plus C? How can I subtract different variables, different alphabets? How can I multiply them, right? And how to even divide them. And also how to solve complex problems related to them, right? But the question is, when these alphabets are so important that a different branch, algebra, is constructed for them, then there has to be some term given to these English alphabets, isn't it? Right. So let's see what term, what name is given to these alphabets. Right. So let's have a look. So the name given to these alphabets, these English alphabets in the branch of mathematics, algebra, is variables, as you can see. Now, what are variables? Variable is derived from the word vary, which means to change. So something that keeps on changing its value means whose value is not fixed. It is getting changed again and again. That thing is known as a variable. Now, the question is, why are we calling these alphabets as variable? There has to be some reason behind it, right? So we are calling these alphabets X, Y, Z or any English alphabet as variables because in algebra, these alphabets act as containers which can store different values in them depending upon the situations. For example, X can have a value 2 in one quotient, right? This X can also have a value 105 in some other quotient. Even this X can have a decimal value in some other quotient, right? It could be 2.3, 2.8, any value. So the value of X keeps on changing. It is not fixed, right? It keeps on changing. It's not fixed. That is why these alphabets are known as variables in mathematics, in algebra. Are you getting it? Right? Now, so this is the main thing on which the entire algebra is based on. Now, there is one more thing which is just opposite to these variables and which is also of utmost importance in algebra. What is that thing? The thing is constant. Again, everything is hidden in the name itself. Constant. As soon as I say the word constant, doesn't it seem familiar to you? For example, if I say the train is traveling at a constant rate, what do you think I mean by it? It means the speed of the train is constant. It is the same. It is neither getting increased nor decreased. Right? Let us consider an example. If I say the train is traveling at a constant speed of 100 kilometers per hour. As soon as I inserted the word constant in it, it means the speed of the train can't be increased. Also, it can't be decreased. It will remain the same. It is constant. So from there, this definition comes that constant is something that doesn't change its value or whose value is fixed. Right? So that is why all the numbers in mathematics, be it negative numbers, positive numbers, fractions, decimals, all these numbers comes under the category of constants. Why? Because their value is fixed. -3 would remain -3 no matter in which question you are using it. 100 would remain 100. It will not change its value depending upon the situation or depending upon the question. It is not a container. It is a fixed value. I hope it's clear. Right? Now, let's move forward and learn about the next concept, which is algebraic expression. Now, for anything to be an algebraic expression, two conditions are required. First one is there has to be at least one variable in it. We have learned what is a variable. Variable for containers which can hold different values in them, like all the English alphabets. So anything to be an algebraic expression, there has to be one alphabet or one variable in it. Second thing is there has to be at least one mathematical operation in it. It could be addition, it could be subtraction, it could be multiplication or division. Right? At least means there has to be one, there could be more, but one is mandatory to be there. Right? Let's consider the examples. For example, when I say x is an algebraic expression. Let's check the condition. First condition says there has to be at least one variable. So x is having a variable x in it, right? But second condition should also get satisfied, which says there has to be one mathematical operation. Now tell me, where in this x is where can you see the mathematical operation of addition, subtraction, multiplication, or division? Is it there? Yes, it is. Why? Because x can always be written as x times 1. Right? It is not changing its value. X times 1 is x only. So we do have a variable. We do have a mathematical operation of multiplication. That is why x is an algebraic expression. I hope it's clear. Right? Now, let's consider the other example. The next one says y plus 2. Again, in this, there is one variable which is y. Also, there is one mathematical operation which is addition, right? Similar way, if I look at the third example, z minus 7, there is one variable which is z and there is also one mathematical operation of subtraction, right? Now let's look at the last example, which is of division. There is one variable which is p and there is also a division symbol. That is why it's p over 5, which is making it an algebraic expression, right? Now let's consider the other example, which is x square plus y minus 2. Okay, so in x square plus y minus 2, as we learnt, there has to be one variable. There is one variable which is x square and there is one addition sign also. So it is an algebraic expression. As you can see, there are more than one variable, right? There is x, there is y, and there is also more than one mathematical operation. As there is addition, there is subtraction, but that is not making it, this is not creating anything that will make it out of the category of algebraic expression. It will remain an algebraic expression because for anything to be an algebraic expression, as we have learned, we need at least one variable and one mathematical operation. If there are more, it's fine, right? Similarly, in x, y, there is one variable. In fact, there are two variables. right? And there is a hidden multiplication sign between them because xy means x times y. Fine? Okay, now let's move to the last thing of the topic, which is terms of an algebraic expression. Now, what are terms in an algebraic expression? Anything that is separated using an addition in an algebraic expression is known as the term of the algebraic expression. For example, x plus y plus 3 is an algebraic expression, right? Because there is one variable and there is at least one mathematical operation. So, if you look carefully, x and y, they are separated using addition symbol. So that is why x is one term, y is one term. Again, y and 3 have been separated using addition. So y is one term, 3 is one term. Similarly, in x over 4 plus 5y minus 2z plus 7, how many terms are there? There are 4 terms. Reason is x over 4, it is separated by 5y using addition sign. And as we have learned, anything that is separated using addition is a term. So x by 4, it is one single term. Do not consider x as one term and 1 over 4 as the other. No, because x over 4 doesn't have any addition sign in between them, right? So x over 4 is one term, 5y is another term. Now 2z, it is minus 2zy because we said anything that is separated using addition sign. This could be written as plus minus 2z, isn't it? Minus 2z could be written as plus bracketed minus 2z. So again 5y and minus 2z have been separated using addition symbol. That is why 5y is one term and minus 2z is another term. Right? I hope it's clear to you. If you have any doubt, you can ask in the comment box. And thank you for your time.